It looks like you need a double loop to check every pair, but the real trick is to store each number's count in a hash map and use a complement lookup instead.
The task is to build a data structure that supports two operations. The first operation, add, inserts an integer into the collection. The second operation, find, returns true if any two distinct numbers in the collection sum to a given target value, otherwise false. For example, if we add 1, then 3, then 5, a call to find with target 4 should return true because 1 plus 3 equals 4, while a call to find with target 7 should return false because no two numbers add up to 7.
A straightforward way is to keep all added numbers in a list and, when find is called, loop over every possible pair and check their sum. This uses two nested loops, so the time for each find call grows with the square of the number of elements, O(n) squared. Adding an element is cheap, big O of 1, constant time, and we only need linear extra space for the list. While simple, the quadratic skin becomes prohibitive as the list grows.
The key insight is to record how many times each value appears. Then for a target we only need to see if the complement exists. We declare a dictionary that maps a number to its frequency. When add is called we increment the count for that number, creating a new entry if it isn't there yet. For find we iterate over each unique key in the dictionary, compute the complement as target minus the current key, and check two conditions. The complement must be present, and if the complement equals the current key we need at least two occurrences. If both hold we can immediately return true, otherwise we continue. If we finish the loop without a match we return false.
Let's walk through the example. We start with an empty dictionary. After add 1, the dictionary holds 1:1. After add 3, it becomes 1:1, 3:1. After add 5, it becomes 1:1, 3:1, 5:1. Now we call find 4. We look at the first key, 1, compute complement 3, see that 3 exists and is different from 1, so we return true right away. Next we call find 7. We examine key 1, complement 6, not in the dictionary. Then key 3, complement 4, also missing. Then key 5, complement 2, missing as well. No pair satisfied the condition, so we return false.
You'll recognize this pattern whenever a problem asks you to support frequent inserts and occasional pair sum queries. Think of any add and find scenario as a candidate for a frequency map.
Each add operation runs in constant time, big O of 1, constant time. Each find operation scans the unique keys, so its time is linear in the number of distinct elements, big O of n. The dictionary stores each distinct number once, giving big O of n space.
That's the HashMap trick for two-sum III. Try implementing it yourself, then move on to the next problem that uses the same design pattern. If you found this helpful, hit like, subscribe, and ring the bell for more algorithm deep dives.